Welcome to lecture 9.2. In this lecture, we will discuss the fourth step to optimal monetary policy. So let's get started. Now, to give you a preview, in this lecture, we will first discuss in greater detail the monetary rule that we studied in the previous lecture. Second, we will discuss the fourth step to optimal monetary policy, which is the IS curve. As far as the learning objectives are concerned, after this lecture, you should understand how does the central bank preference parameter beta affects the monetary rule. Second, you should understand how does the slope of the Phillips curve affects the monetary rule. And finally, you should understand what we mean by the IS curve. Okay, so to begin with, if we recall the previous lecture, we graphically derived the monetary rule and we showed that the monetary rule is represented by this equation. Now there are two key questions that we want to answer with regards to the monetary rule. First, we want to understand how does the central bank preference parameter beta affects the central bank's monetary rule. Second, we want to understand how does the slope of the Phillips curve gamma affect the central bank's monetary rule. So let us first understand the relevance of beta and how the central bank preference parameter affects the MR curve. So if we begin with the case where the central bank preference parameter beta is equal to 1, we know by now that this implies that the loss indifference curves are in the form of circles, correct? Now let us assume that the economy is hit with a negative supply shock, and as a consequence, the Phillips curve is not passing through the bliss point A, but is as shown in the figure. And as we have learned from the previous lecture, the MR curve, MR1 in this case, passes through point A and point C. Now what happens if the central bank preference parameter beta is greater than 1? As we know from lecture 8.3, in that case, the central bank loss indifference curves are in the form of an ellipse that are stretched horizontally and compressed vertically, as is shown in this figure. What is the consequence of this? Well, as you can see, for the same Phillips curve, the optimal output inflation combination is given by point D, which is the point of tangency between the Phillips curve and the ellipse. As a consequence, the new MR curve, MR2, is the one that passes through points A and D. As you can see, the new MR curve is flatter than the old MR curve. Hence, as the central bank preference parameter beta increases, the MR curve becomes flatter and flatter. And with the same logic in reverse, as the central bank preference parameter beta is less than 1, the MR curve will have a more steep downward slope than MR1. And what does a flatter MR curve mean in this instance? What this means is that the central bank attaches more importance to the inflation target than to output target. In other words, a central bank with beta greater than 1 will cut more output in response to a given inflation shock relative to the case when beta is equal to 1. On the other hand, a central bank with beta less than 1 will cut less output in response to a given inflation shock relative to the case when beta is equal to 1. Now let us understand how the slope of the Phillips curve gamma affects the MR curve. To begin with, let us assume that gamma is 1, or in other words, the slope of the Phillips curve is 45 degrees. And assume the Phillips curve was initially passing through point A, but then the Phillips curve shifts up due to an inflation shock such that the inflation at equilibrium employment or equilibrium output is given by point B. Now, as we know from the analysis in the previous lecture, the central bank can do better by choosing point C, where output is a bit lower than equilibrium output and inflation is not as high as point B. MR1 is the resulting MR curve that passes through points C and A. Now, what happens if the slope of the Phillips curve is greater than 1? We know from lecture 8.3 that as gamma increases, the Phillips curve becomes steeper. Hence, in this case, the Phillips curve is as shown by PC gamma 2. The new Phillips curve also passes through point B. What it means is that due to the inflation shock, the economy is still at point B, same as before. But now, because the PC is steeper, the optimal output inflation combination that the central bank can achieve is given by point D. And as you can see, point D is closer to point A relative to point C. Hence, the central bank's loss is smaller in this case. Also, the MR curve in this case is given by MR2, which passes through point D and A. As you can see, the MR curve is flatter in this case as well. Hence, as gamma increases, the MR curve becomes flatter. And on the other hand, as gamma decreases, the MR curve becomes steeper. And what is the implication of a steeper Phillips curve and a flatter MR curve? Well, as we can see from the previous slide, any given cut in output has a greater effect in reducing inflation than when gamma is equal to 1. What this implies is that the central bank gets a bigger bang for its buck. Or in other words, the central bank gets a bigger fall in inflation for a given cut in aggregate output. Hence, in response to an inflation shock, the central bank cuts aggregate output by less relative to when gamma is equal to 1. Okay? Now, this gets us to the fourth and final step towards our study of optimal monetary policy, and that is the IS curve. Now, what is the IS curve? Well, the IS curve shows all combinations of the real interest rate and output level at which there is equilibrium in the goods market. The goods market is the market for goods and services produced in an economy, and in equilibrium, the aggregate demand for goods and services in an economy is equal to the aggregate output. The IS curve can be mathematically represented by this equation where aggregate output Y is equal to autonomous expenditure A, which we take to be a constant for simplicity, and a negative function of the real interest rate R. Now, if you recall lecture 8.2, when we first introduced the Taylor rule, we had mentioned something called the stabilizing real interest rate RS. Here, we formally define the stabilizing real interest rate as the interest rate that produces equilibrium output in the IS equation. In other words, the stabilizing real interest rate RS is such that capital A minus ARS equals output at equilibrium. As we shall see in the next slide, the IS curve is a downward sloping curve in the interest rate output space. And why is the IS curve downward sloping? Well, the IS curve is downward sloping because as the real interest rate increases, the aggregate output is lower in equilibrium. And why does the aggregate output fall as real interest rate increases? One reason is because as R increases, this causes businesses to reduce the investment spending as borrowing is more expensive in real terms. As a consequence, aggregate investment goes down, and as a consequence, aggregate output goes down. A second reason is that as domestic interest rate increases, foreigners want to buy financial assets that are denominated in domestic currency, which causes the domestic currency to appreciate against foreign currencies. But as the domestic currency becomes stronger, net exports decrease because exports from the home country becomes more expensive for foreigners and imports become cheaper. As net exports decline, so does aggregate output. And that is why the IS curve is downward sloping. The higher is the real interest rate, the lower is the aggregate output. And the lower is the real interest rate, the higher is the aggregate output. For example, if real interest rate is equal to 3%, then aggregate demand is equal to aggregate output at $9 trillion, which is the point A. If the economy is instead at point C, then there is an excess supply of goods. As a result, firms and businesses deplete their inventories until aggregate output falls to $9 trillion. Similarly, if the real interest rate is equal to 1%, then aggregate demand is equal to aggregate output at $11 trillion, which is point B. If the economy is instead at point D, then there is an excess demand for goods, and as a result, firms and businesses increase their investment to satisfy the excess demand, which increases aggregate output, and we have equilibrium in the goods market only when output is equal to $11 trillion. In this example, we have assumed the IS equation to be equal to y is equal to 12 minus r. In other words, we have assumed capital A to be equal to 12, and we have assumed small a to be equal to 1. As you can see, if r is equal to 7%, then aggregate output is 12 minus 7, which is equal to $5 trillion. And if r is equal to 3%, then aggregate output is 12 minus 3 equal to $9 trillion. It is worth understanding that if the equilibrium output for this economy is $9 trillion, then the stabilizing real interest rate would be 3%. Now, if we recall from the previous slides, the IS equation is y is equal to capital A minus AR, and we have the equilibrium output y bar at the stabilizing interest rate Rs. If we subtract the second equation from the first, we get y minus y bar is equal to minus A into R minus Rs. And this is an alternative form of the IS curve. The interpretation is that as the real interest rate is higher than the stabilizing real interest rate, the output is lower than the equilibrium output. On the other hand, if the real interest rate is lower than the stabilizing real interest rate, then output is higher than the equilibrium output. Finally, it is worth understanding that if we change the real interest rate, we move along the IS curve. But changes in some external factors can shift the IS curve. So what are the factors that can shift the IS curve? Well, any of the following factors shift the demand curve to the right. For example, if the economy experiences a positive demand shock, like improved consumer or businesses' expectation, then the output is higher for any given real interest rate, and as a consequence, the IS curve shifts to the right. Similarly, higher government purchases or lower taxes imply that for any given level of real interest rate, the aggregate output is higher in equilibrium. Hence, the IS curve again shifts to the right in this case as well. With the same logic in reverse, a negative demand shock or lower government purchases or higher government taxes imply that the IS curve shifts to the left. So that ends the discussion on optimal monetary policy today. In the in-class lecture, we will put together all the steps that we have learned so far to understand how the central bank changes the real interest rate in order to achieve the output and inflation targets. So that's it for now. Thank you.